Okay guys, the post-assessment for magnetism, this is your last unit, and we've just got 5 questions here, so if you will just follow along with me, I will give you some hints and strategies, and I'm sure that'll really help you to answer the question. So number 1, which diagram illustrates the magnetic field or the magnetic domains of a permanent magnet? Domains are like tiny little magnets themselves, so each domain would have a north and a south pole. So there are regions of an object that can be magnetized, but they're like tiny magnets themselves. And 3 of these stand out. One of them stands out. 3 of them are about the same. And in a permanent magnet, there's a sense of order. There's an alignment of the domains. And I think this is pretty simple to figure out. Number 2. Which type of magnetic field is created by a straight current carrying wire? So if you have a cross-section of a wire, and I'm looking at the wire, we can say the current is coming towards us that way, or the current is going away from us that way. Those are just two ways of representing it. So this one means the current is going into the page, this one's the current's going out, but that's looking at a wire side on. And there's a rule called the right-hand rule, where you can actually point your thumb in the direction of the current. So I would put my thumb into the page there, I'd bring my thumb out of the page here, and your curled fingers represent the magnetic field around that wire. I think if you can imagine putting your thumb in at this point over here, getting your thumb coming towards you at this point here, and the thumb going into the page there, and your fingers curling around the wire to represent it, that kind of gives you an idea about the magnetic field. Another question, I think that's just really easy. Number 3, an electromagnet is constructed by wrapping a current carrying wire around an iron core. Which conditions will produce the strongest magnetic field? So if we have, just say, a normal nail, and we wrap wire around it, and we connect it up to a battery, we're going to get current going through there, and it's going to become magnetized. And you did a simulation this week called Faraday's Law, where you use various types of coils, you change the current in the coils and the voltage, and you basically also change the number of loops. Now Faraday's Law is about generating current with a magnetic field. But you can not only generate current with a magnetic field, current itself generates a magnetic field. So based on the number of loops we've got, based on the current that's flowing through there's something we can say about the magnetic field. And the magnetic field around here is kind of gonna go out from the North Pole and into the South Pole. And I want you just to think logically about what's going to create the strongest magnetic field from the setup. What could we say about the current? What could we say about the number of turns? It's pretty logical. I think you guys could figure that out quite easily. Number 4. What happens when an ideal step-up transformer increases the voltage of alternating current? So if I draw just a simple drawing here of a transformer, let's say there's our iron core, and here's our primary coil, that's where the current goes in, and here's our secondary coil, and my secondary coil has got a lot more loops than my primary coil. So if the current is going in here and out here, this is a step-up transformer, because we've got a few turns going to many turns. Now with a transformer, the power in always equals the power out. And you guys know that power equals VI, voltage times current. So if the power going in and the power going out have to be exactly the same, a step-up transformer is going to step up the voltage. So the V and I on this side and the V and I on this side, if you multiply them, they're going to be the same. So the step-up transformer means the voltage is going up, but when you multiply V and I, you must still get the same answer. So something has to happen to the I when the V goes up, and it's that the I goes down. But the key in this question is that transformers have a constant power in and power out. Or we could also say the energy going in equals the energy going up. Transformers are very efficient. I think I've given you enough hints for that question. The last one, number 5. A transformer triples its input voltage. If the current in the primary coil is 6 amps, how does the current change as it moves through the secondary coil? So, like the equation I've spoken about above, the power in equals the power out. If VI, which is power in, equals VI out, what's happening here, they're saying, is that the voltage is going to triple. So we've got a certain voltage to start with. It's going to go up 3 times. If the voltage goes up 3 times, something has to happen to the current. So V is going up 3 times. Something has to happen to the I for us still to get the same answer for V multiplied by I. V multiplied by I has to stay the same. Your power, which is V times I, has to not change. If the voltage is going up 3 times, basically what is going to happen to the current? And that's it. Please post any questions in class comments if you have any questions.